So section 2.8, something called the rational roots theorem. Okay, this is going to be a theorem that we're going to use to help us factor polynomials. Okay, there's a sarcastic question up here. So in the previous things, I always said factor this polynomial, but I would always give you what? One of the roots. Okay, this is asking you, doesn't it feel like it's cheating when I give you one of the roots? Would you like to be able to do this without getting any clues or hints? This is when you would say, yes, we would. Okay, so that's so anyway, that's where we're going. So whether or not your opinion didn't really matter on that one, that's where we're going. Okay, so rational roots theorem. This is what a polynomial looks like. I know it looks complicated. This is a coefficient of x to the n, the coefficient of x to the n minus 1. It's just a way of writing a polynomial. It could be 5th degree, 4th degree, whatever. If this polynomial has rational roots. Now, they're not guaranteed to have rational roots, but if it has rational roots, it's going to be the form plus or minus p over q, where p represents all the factors of the constant term, and q represents all the factors of the leading coefficient. Okay, the leading coefficient is what number? Where is it found? What is the leading coefficient? The number in front of the degree of highest order, so the highest degree term. Okay, so if this has rational roots, it's going to be in the form p over q, where p represents the factors of the constant, q represents factors of the leading coefficient. Okay, now we're going to run across these, and over time, these will just become part of your memory, these little shortcuts here. But if all the coefficients add up to 0, then x equal 1 is a root, or x minus 1 is a factor. That's just one of those things that's like a trick you want to have up your sleeve when you're starting to factor. Do the coefficients add to 0? That tells you where to start. And the other one we'll see in a moment, if all the coefficients are positive, if it has a root, the root has to be negative. Okay, you'll see why these are important, because these shortcuts can save you a little bit of time. So let's look at this. Let's find all the possible rational roots. So I'm coming up with a list of, if I was told to factor this, where would I start? Okay, well, the roots are going to be, if it has rational roots, it's going to be plus or minus the factors of the constant term divided by factors of the leading coefficient. What is the constant here? It's what? Negative 10. But since I've got a plus or minus there, I'm just going to write 10. I don't really care about the plus or minus. So are you okay, Lucy? Do you need to? Sure. Is it ink or something? Or? So, if it has rational roots, it's going to be in the form plus or minus. Well, because I've got a plus or minus in front of it. So plus or minus 10 is the same as plus or minus minus 10. So I dropped the negatives. So it's going to be plus or minus the factors of 10. What's the leading coefficient? 1. So plus or minus the factors of 10 divided by the factors of 1. Okay? So now this becomes, what are the factors of 10? It's 1 times 10, 2 times 5, and that's it. Okay? Those are all the factors of 10. What are the factors of 1? 1. Okay? So if there are rational roots to this, it's going to be plus or minus the factors of 10 divided by the factors of 1. Now what I just have to do is this one's pretty easy. What's every number in this list? What is every number in that list divided by 1? It's just that list. Okay, so my possible rational roots are plus or minus 1, 2, 5, and 10. So if I told you to factor this and I did not give you any of the rational roots, there's no sense trying 4 or 6, or 3. If it has any rational roots, it has to be in this list. Okay, so this gives us a list of how many numbers? 1, 2, 3, 4, 8 numbers. Okay, so the worst case, I might have to do synthetic division, 8 times until I get success. Okay, yeah, Kyle looking like. But you guys are experts at it. You're becoming easier with it. So it's better than doing long division 8 times. But what's going to happen is now you're going to have to try until you get a successful root. So you'll do synthetic division with that. So I'm not sure if this one works out. We'll work out some more later. But what I'm after now is just you identifying all the possible rational roots. So the possible rational roots here, it's going to be plus or minus the factors of what? Factors of 6 divided by the factors of what? Of 1, okay? So the factors of 6 over the factors of 1. What are the factors of 6? Yeah, 1, 2, 3, and 6. The factors of 1 are just 1. So the possible rational roots are just plus or minus 1, 2, 3, and 6, okay? So if I needed to factor this down to a quadratic, I've got to try these numbers until I get a 0 remainder. Okay, let's look at another one, I think that has more possibilities here. So if this has rational roots, it's going to be plus or minus the factors of what? Yeah, factors of 24 divided by the factors of what? Of 21. So plus or minus the factors of 24 over the factors of 21. So this is plus or minus. This one's going to be a little bit of a longer list. Factors of 24, that's 1 times 24, yeah, 2 times 12, 3 times 8, 4 times 6, and then I start, yeah, so I see that 2 times 12 and 24. Those are all the factors of 24, okay? What are the factors of 21? It's 1 times 21, 3 times 7, and 21. That's it, okay? So this is going to be a longer list, okay? Because it's every number here divided by every number here, okay? So this list is going to be plus or minus. The way I always do it is just start like, let's divide every number you see there by 1. Okay, that's pretty straightforward. Okay. Then I'm going to divide every number in that list by what? By 3. I'm just going to go in order. I'm going to get what? 1/3, 2/3, and I try to save it. What is 3/3? 1. That is already on my list. Okay. Then I've got 4/3. What is 6/3? That is 2. And then I've got 8/3. What is 12/3? That's 4. 24/3 is 8. Okay. Now I divide every number by 7. I'm going to get 1/7, 3/7, 4/7, 6/7, 8/7, 12/7. Did I skip? Oh yeah, 1/7. Yeah, 2/7. I like to write them in order, so let me just back up then. So 1/7, and then we had what? 2/7, 3/7, 4/7, 6/7, 8/7, 12/7, 24/7. Now I divide every number by 21, and I get 1/21, 2/21, 3/21, 4/21, 6/21, 8/21, 12/21, and 24/21. Those are all the possible rational roots for this polynomial. How many are there? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, plus or minus, that means 56 possible rational roots. So if I hated you guys, I would make you, I would give you a list like this and make this be the one that works, you know, at the very end. No, but that's not what's going to happen. So you need to be able to create a list like this. These are all the possible rational roots. But when it comes to you finding one that works, just start going down this list, and you're going to find success, you know, somewhere in this area. My goal is not to be the one here that makes it work, okay? My goal is not to make you go through this 12, 13, 14 times until you get one that works, okay? So this would be a problem. I might ask you to list the possible roots like this on a test, but this is probably not one that I would make you then go find the roots. It's a little bit complicated. Yes? You're right. 321 is 1/7, so which is right there. So I'm okay if you. It just saves you from writing that one down, but I won't count off if you write it twice. Okay. I just tended to miss that one, and I think this would simplify as well. That's what That's 8/3 or 8/7, 8/7, which I already have. But I mean, you're okay to not simplify for this. It's all right. So anyway, this will be an ugly problem if I made you start going through and finding the answers, and that was the one that worked. Okay. So we'll probably break this problem up, like give you an ugly problem that just makes you list the possibilities, but you'll see the ones that I actually have to work on probably won't make them that bad. So here's what we need to do. I want to factor this polynomial, and I did not give you any information about what one of the factors or roots are. So what you need to do is you need to figure out what are all the possible rational roots. So it's going to be plus or minus the factors of what number? Yeah. So factors of 35 divided by the factors of what? Factors of 1. You got to like it when 1 shows up because that one's pretty easy. So what are the factors of 35? That's plus or minus 1, 5, 7, and 35. So that represents there are 4 numbers. There are 8 possibilities here, okay, in order to make this work. Well, you've got plus or minus. You got 1, 2, 3, 4 numbers, plus or minus, okay? So I just need to find one that works. Now, what happens when you substitute 1 into this equation, okay? When I put a 1 in, if it is a root, what will I get back? If it's a solution, what will I get back if I put a 1 in there? For any number, if I say it's a root or a solution, when I plug it in, what number do I get back? Not the same. Not 1. There's one number. If it's a root or a solution or a 0, when I plug it in, what do I get back? 0, okay? So if I were to plug a 1 in here, what's 1 plus 3? 4. 4 minus 33 minus 35. I'm not sure what that is, but it's not 0. It's not 0, okay? So in this case, if these numbers add to 0, then 1 is a root or solution. Because if I were to plug in a 1 here and get a 0, that means 1 is a solution. So that would say start with 1, okay? So that just helps you save time. So I know that 1 will not work here. Now there's no harm in you trying it, okay? It's just a shortcut that if these numbers add to 0, 1 is a solution, okay? This case, it didn't happen to be that way, but if I don't recognize that, I'm not going to lose a lot of time working this out. So what I need to do now is I just need to go until I get one of these answers that works, because I'm starting out with a 3rd degree, and I want to get it down to a quadratic. So let's just try 1. Suppose you didn't recognize that, so let's start with 1. And let's see, I'm going to have 1, 3, negative 33, negative 35. So if I bring the 1 down, 1 times 1 is 1. Add to get 4. 1 times 4 is 4. That gives me negative 29. This is negative 29. Now, I really don't care what this number is, but I know it's not what? It's not 0. So when I get this far, that didn't work. So 1 is not a root or solution, okay? So it doesn't matter. Those add up to be, what, negative 64. All I know is it's not 0. So 1 does not work. So I'm going to try negative 1 now. So I'm going to try this same problem with negative 1. So if I bring the 1 down, 1 times negative 1 is negative 1. 3 minus 1 is 2. Negative 1 and 2 is negative 2. Add those to get negative 35. Negative 1 and negative 35 is 35. Add those to get 0. That's what you want, okay? That means 2 things. That means x equal negative 1 is a solution. What else does it mean? What's the factor? What is a factor?
Oh, x plus 1.
X plus 1. So x plus 1 is a factor. Now you need to be able to go back and forth between x plus 1 is a factor, x equal -1 is a solution, okay? So now I can write this polynomial f of x. What are its factors now? X plus 1. And what does this mean? X squared, what? Plus 2x minus 35. Okay. So now I've factored the cubic to a linear term and a quadratic term, and then we're back to that skill that you got to know is how to factor the quadratic. So two numbers that multiply to -35 and add to 2. Those numbers are what? Yeah, 7 and -2. Okay. 7 and 5. Sorry. So 7 and -5. Because this starts with an x squared, what can I do with those numbers? Yeah, that's my factorization. So this is x plus 1, and then what? X plus 7, x minus 5. Okay. So write this polynomial as a product of its factors. That's another word for just saying factor this. This is completely factored. Okay. What if I ask you what are all the roots? What are all the roots to this polynomial? -1, -7, +5. Okay. So again, what we did here, find the factors of this number divided by the factors of that number. That gives me a list of all possible rational roots. My goal, like I said, is not for you to go down this list of 8 numbers and the 8th one works. And I said, gotcha, you know. So yeah, I designed these to not be as ugly as they look. Okay, so somewhere you're going to get success. But here's the deal. If you make an arithmetic mistake on here, you're not going to get this one right, and then you're going to go to the next one. Okay, then you're going to feel frustrated, like I lied to you, that I'm making you go down a long list. So you got to find ways to correct your arithmetic mistakes, you know, or if you need a calculator, check all of those. Okay. So let's do a few more of these. Oh, and I guess I did all of that here. Factor the quadratic, listing all the zeros. Let me do that. That was x equal what? -1. What else? What? 4? No. -7 and +5. Right. Those are all the zeros. Okay. So let's look at the next one here. Possible rational roots. It's going to be plus or minus the factors of what number? Yeah, the factors of 2 divided by the factors of what? Of 6. So this is going to be plus or minus factors of 2. You got to like that number. It's just 1 and 2. Factors of 6 are what? Yeah, 1, 2, 3, and 6. So my list, you divide every number by 1. That's 1 and 2. Divide every number by 2. That's 1/2. What is 2/2? 1, okay? Now divide every number by 3. And I get 1/3 and 2/3. Now divide every number by 6. And I get 1/6. What is 2/6? 1/3. So I'm not going to write that down. If you wrote it down twice, no big deal. But when you come to testing them, I like to have as small a list as possible. Okay, these are all my possible rational roots. And sitting here, you are hoping that it's not which ones? You're hoping it's not any of the fractions. So chances are you're going to get your wish come true on most of these. Now, before I get started, let's add these numbers up. What's 6 plus 1? 7. What's 7 minus 5? 2. What's 2 minus 2? 0. What does that tell me? X equal 1 is a solution. X minus 1 is a factor. Because what happens is, if there's a 0, when you plug in that number, you get 0. If I plug in a 1, I get 0. So when I add all these up, the coefficients, these coefficients add to 0. That means that x equal 1 is a root or solution. x minus 1 is a factor. How does that help me? Yeah, instead of guessing around, what do you think I'm going to start with? I'm going to start with that one. So if I start my synthetic division, and let's see, that's 6, 1, minus 5, minus 2. Bring the 6 down. 1 times 6 is 6. Add that to get 7. 1 times 7 is 7. 7 minus 5 is 2. 1 times 2 is 2. Add that to get 0. Okay? So now we know that we have f of x is, what are its factors now? Yeah, 6x squared plus 7x plus 2, and then what's the other factor? X minus 1, okay? Okay. So now it's all, this problem has now boiled down to factoring a what? A quadratic, which is something you thought you left behind last semester, but no. So I need two numbers that multiply to give me a 12 and add to give me a 7. Those numbers are what? Yeah, 3 and 4. So I need to write, what, 6x squared plus 3x plus 4x plus 2. Factor that by what? Grouping. So I get a what? 3x, and I'm left with what? 2x plus 1, plus, if I factor a 2 out of the next one, I'm left with 2x plus 1. What is this factorization? Yeah, so 3x plus 2 times 2x plus 1. So what is my final factorization of this polynomial? Yeah, so don't forget the x minus 1 you started with, and then it's 3x plus 2 and 2x plus 1. Okay, so now this is completely factored. Now, if I were to ask you for the roots or the solutions or zeros, all those words mean the same thing. What are they? 1, yeah, negative 1/2, and negative 2/3. Now, are these on my original list? Or, yeah, all of these numbers are on my original list. Plus or minus 1, 1/2, 2/3. So if you'd have started down that list trying 2 and 3, those things wouldn't have worked. It would have taken fractions. So you're going to have fractions as your answers, but as long as there's an integer that happens that you can guess to get it down to a quadratic, it's not, I mean, this is not that difficult, factoring a quadratic and getting fractions as your roots. It's doing synthetic division with fractions that I think you guys are not wanting to do. And I think for the most part, we can keep those dreams alive for you, okay? Now let's look at the next one here. What are all the possible rational roots here? So it's plus or minus factors of what? Yeah, factors of 6 divided by the factors of 2. So this just becomes an exercise of listing all these numbers. What are the factors of 6? Yeah, 1, 2, 3, and 6. And then the factors of 2 are just 1 and 2. So I need to take every number in the numerator here and divide it by the denominator. Divide every number by 1, then every number by 2. So this is plus or minus 1, 2, 3, and 6. And then divide each of those numbers by 2. And I get 1/2. What is 2 halves? 1. And then I get 3 halves. And then what is 6 halves? 6 halves is 3. That number is already on my list. So I've got how many possibles here? Yeah, so 6 numbers plus or minus, that means 12 possible solutions. Now, let's try, let's add these numbers up. 2 plus 11. First of all, what you're trying to determine when you add the coefficients, you want it to be what? 0. Without doing that, do you think it's 0? Why do you think it's not 0? They're all positive. So whatever that number is, I can waste brain cells trying to figure it out, but I know it's not 0. Okay, so I know 1 is not going to work. Okay, so if this is what 2, that's 13 plus 17 is 30, 36. So it is 36, but I know it's not 1. So 1 is not a solution. Okay, now to see why, I just want to try that just so you can see why. So if you do synthetic division with 1, so you've got 2, 11, 17, and 6. So if you bring the 2 down, what's 1 times 2? 2. 11 plus 2 is 13. 1 times 13. These numbers are getting what every time? Bigger. There's no way it's going to hit 0. So 1 is not a solution, and what else is not going to work? Any other positive number, okay? So if I were to try 2, it's not going to work. So what I can do when all the coefficients are positive, don't waste your time on positive roots, okay? So this list of, 12 numbers is now a list of what? 6 possibilities, okay? So I've eliminated half of them. So in this case, because all the coefficients are positive, the root has to be negative. Now, if you didn't get that, you'll just start going down this list. 1 and -1, 2 and -2, 3 and -2, okay? It's not going to hurt you. You'll just be doing a little bit extra work. So I know that 1's not a solution. So if I usually just march down this list from left to right. What do you think I'm going to try next? -1. I'm not going to try 2. I would try -2. So I'm just going to start trying the negatives of all these numbers. So let's test it with a -1. So 2, 11, 17, and 6. You bring the 2 down. -1 times 2 is -2. Add those numbers to get 9. -1 times 9 is -9. 17 minus 9 is 8. When I get this far, okay, I can tell it's not going to work, right? -1 times 8 doesn't give me -6. So, I'm pretty good with just saying, I know that's not 0, okay? If you need to go all the way through, you can do this and find out, okay, it's not 0. So it doesn't matter to me that that number was -2 or -3 or -4. What matters is that it's not what? Not 0, okay? So I know the positive numbers don't work, -1 doesn't work. What's the next number I'm going to try? Yeah, I'm going to go with -2, okay? So let's try -2, 2, 11, 17, and 6. You bring the 2 down, multiply here and get -4. Add that to get 7. -2 and 7 is -14. Wake up, Kyle. 17 minus 14 is 3. -2 and 3 is -6. And the bells go off, ding, ding, ding. So we are successful. This means that what? X equal -2 is what? A solution. What's the factor? Yeah, x plus 2 is a factor. You don't have to write that down, but I like writing that down because then the next thing you're going to ask me are either the factors or the solution, okay? So in this case, what are the factors now? F of x is what? X plus 2, 2x squared plus 7x plus 3. Okay. So I need to now factor this. So I need 2 numbers that multiply to give me a 10, multiply to give me a 6, and add to give me a 7. So that's what, a 1 and a 6? So I can write this as 2x squared plus x plus 6x plus 3. And the first terms I factor out of what? X, and I'm left with what? 2x plus 1. And then I factor out a 3, 2x plus 1. So this is what? X plus 3 times 2x plus 1. So what is my final factorization? X plus 3, 2x plus 1, And one more, x plus 2. Don't forget the first one that you had, okay? If this is a third degree polynomial, I'm expecting 3 factors there, okay? So I've got all 3 factors. What are the roots or the solutions? Yeah. So x is what? -2, -3, and what? -1/2. Okay. Yep. So again, this is sort of logical, okay? This is more arithmetic than it is algebra, okay? So the thing that's new is finding possible rational roots, and then you just have to methodically go down that list until you find one that works. Now, when you start with a third degree polynomial, you need to get synthetic division to work how many times until you get to a quadratic? Start with a third degree polynomial. How many synthetic divisions have to work before I get to a quadratic? Come on. Third degree polynomial. It starts at, that's something x to the what power? Third. How many times does synthetic division have to work until I get to a quadratic? One time. Yeah, one time it has to work. So when I get synthetic division to work one time, I'm down to a linear and a quadratic. If I start in what we'll do the next lesson, if I start with a fourth degree polynomial, how many times will synthetic division have to work before I get to a quadratic? 2 times, twice, and that's what we're after. So there we are. I want to just do one more. I've got one on the board. Let me just write it down here so it'll be in the notes. Let's factor this guy. Do I have a volunteer? Okay, Kyle. Are you awake from your nap? I don't want to have to give you hazard pay for this.
It was tough.
Sometimes it's just so exciting. There's nothing to do. Math just calms you. Is that what you're saying?
I like telling myself to focus.
So x cubed plus 6x squared. Read that off to me. What is it? Plus, is that 11x?
Yeah, plus 6. Just 6.
So I want to factor and find all roots. Okay? So first of all, so Kyle's going to work on this one for us. So first of all, find all. It's over here. No, you do it over here. That way it'll be recorded for all of time on YouTube. It's going to make you a viral sensation. So what are all the possible rational roots? Yeah. Factors of 6 divided by factors of 1. Okay? I like it when 1 is on the bottom because this is basically just the factors of what? 6. Okay? So. Okay, so it's plus or minus 1, 2, 3, 6. Okay? Now, do the coefficients add to 0? Okay, so I am not going to start with 1. Okay? What else do I notice about these coefficients? They're all positive. So that means I'm not going to try any of the what? Positive numbers. So there are only 4 numbers there I'm concerned about. -1, -2, -3, and -6. So your choice. Yeah, so Kyle is going to start with -1. Yeah, okay. You must be living right today, so the first one worked. So now, this is what? X plus 1 is a factor, x equal -1 is a solution. So what is, yeah, go ahead and write that down. So now write f of x as what factors do you know at this point? What are you trying to do? Well, so hold on. You're not having enough space over there. So why don't we just, So what is f of x?
That's the first one.
Times what? Okay. So you need numbers that multiply to 6 and add to 5.
6 and
Not quite.
add to 5.
Yep.
Oh.
You're
2
getting.
and 3.
You want to call a friend? Okay, yeah, 2 and 3. So this is.
Shoot. I do it over here.
You can do it over. Well, I mean, you've got the numbers. It should be easy at this point.
That's like doing it like separate. Now
Okay.
I'm gonna write the answer over there.
Okay. I don't want to mess with your mojo then.
Oh. Chill. Down.
So f of x, he's keeping us in suspense, is x plus 1, x plus 2, and x plus 3. Very good. What are all the solutions to this?
-1, -2, -3.
Okay, very good. Okay, so
That's all.
very good, very good.